This is the content of our quiz last time, where you are asked to determine the number of significant figures. So we have five items. Number one is 0.00450. Number two is 206. Next, we have 1.080 times 10 to the 3. We have 500 with no decimal. And lastly, we have 0.0000007. So for item number one, for 0.00450, so we only have three significant figures for this. Um, Leading zeros don't count, trailing after decimal. Okay, so 0.00450 only have three significant figures. The significant figures are 4, 5, and 0. For item number 2, we have 206. All right, take note that the 0 number is in between the two non-zeros. So we have three significant figures, meaning all non-zero plus the captive zero. So meaning the captive zero, the zero at the center, in between that number 2 and number 6. Now, item number 3, we have 1.080 times 10 to the 3. Now, in this case, this item is in scientific notation. So, we have four significant figures in this case, meaning all digits in the coefficient count are all significants. All right. Now, next is 5.00, which has no decimal. So we only have one significant figure for that. Okay, so we will not include the two zeros here after the 5. Okay, and the last item, 0.000007. Okay, so in this case, um, we only have one significant figure, and that is number 7. Now let's proceed to quiz number 2. So you are tasked to convert these numbers to scientific notation. So for item number 1, we have 25,000. Next is 0.000730. Then 4,020. Then 0.008. And 602 million. Okay, so to convert the item number 1, we're going to move the decimal point. So it is assumed that after the last zero, we have the decimal point here, and we're going to move that one to the left. So that becomes 2.5 times 10 to the 4. All right. So why is it it's positive 4? Because we're moving from right to left. Now the second item, we have 0.000730, and our significant notation, I mean the scientific notation for this is 7.30 times 10 to negative 4. So why is it? It is negative 4 because we are moving our decimal point from left to right. Okay, 4 times. That is why it is 4. And then from left to right, negative. All right. Now, next item, 4,020. So the scientific notation for this is 4.02 times 10 to the 3. Take note, it's positive 3. That is because we assume that the decimal point is after 0, and we move that decimal point to the left. So 3 times. So to 0, to 2, and another 0. So that becomes 4.02. So our scientific notation for this number is 4.02 times 10 to the positive 3. Now, second to the last item, we have 0.008. Our significant notation for this is 8 times 10 to the negative 3. Now, you observe that there's no decimal point written after the 8 here. Okay, so this is also the other way of writing the scientific notation. We can also write 8.0 as the coefficient. Okay, but for the sake of simplicity, we're not going to include that one here. So our final answer, the scientific notation of this 0.008 is 8 times 10 to the negative 3. Now, the last item we have 602 or 602 million. So we're going to count how many decimal places that we move. Okay, so first 3, another 3, so that is 6, then 7 and 8. So that is why we have 6.02 times 10 to the positive 8. Now let's proceed to the addition and subtraction of scientific notation. So we have three rules for this. Rule number one, you're going to rewrite the number with the smaller exponent so that it has the same exponent as the number with the large exponent by moving the decimal point of its decimal number. Okay, and number two, you're going to add or subtract the decimal numbers so the power of 10 will not change. And lastly, you're going to convert your result to a scientific notation if necessary. Now, example number one. Now, in example number one, we have same exponent here. So we have 5.7 times 10 to the 3 plus 2.3 times 10 to the 3. So um, you're just going to add 5.0 and 2.3, meaning the coefficient, and retain the base and the exponent. So times 10 to the 3. So 5.7 plus 2.3, that is equal to 8.0 times 10 to the 3. Now next, example number 2. In example number 2, we have different exponents here. We have 3.6 times 10 to the 5 plus 8.2 times 10 to the 4. So what we're going to do is we're going to change the lesser exponent into the higher one by moving the decimal point to the left. Okay, so we have 3.6 times 10 to the 5. We're just going to retain that one, and the 8.2 becomes 0.82 times 10, and then change the exponent to 5. Now if the exponents are the same, we can now simply add the coefficient 3.5 and 0.82 and copy the base and the exponent. So we have the final answer 4.42 times 10 to the 5. Now we have another example, example number 3. In this case, we have negative exponents. So the items are 9.5 times 10 to the negative 3 plus 2.1 times 10 to the negative 4. So as what I've said, we're going to change the lesser exponent into the bigger exponent. So we're going to change negative 4 into negative 3. And by doing so, we're going to move the decimal point um, from its original position to the left. So that is why from 2.1 it becomes 0.21. So if the exponent are the same, we can now simply add the two coefficient 9.5 and 0.21. So we have 9.71 times 10 to the negative 3 as our final answer. Now we have here example number 4, which we renormalize the answer before we arrive with the final answer. So the given, we have 6.8 times 10 to the 2 plus 4.5 times 10 to the 2. So since they are of the same exponent and base, so we're just going to add all the coefficient, the 6.8 and the 4.5. So we have 11.3 times 10 to the 2. However, 11.3 is not the final or the standard format, so we're going to move the decimal point to the left and having one digit before the decimal point. So our final answer will be 1.13 times 10 to the 3. Now next, example number 5. This is for large exponent gap. So the given is 2.35 times 10 to the 6 plus 4.1 times 10 to the 3. Okay, so now in this case, we're going to change 4.1 times 10 to the 3 into similar with the other number that has 6 exponent. So by doing so, we're going to move the decimal point from its original position to the left, and our final form is 0.0041 times 10 to the 6. Now in this case, we're going to add 2.35 and 0.0041. So we have 2.35 plus 0.0041, and that is equal to 2.3541 times 10 to the power of 6. Now we have 4 practice problems here, and I want you to solve these 4 items, and just pause this video and check the your final answer later. Now these are the answers for the 4 items. Now for letter A, the final answer is 1.10 times 10 to the 5. Letter B, that is 1.9 times 10 to negative 2. Letter C, 3.87 times 10 to the 6. And letter D is 1.36 times 10 to negative 6. So I hope you got a perfect score. Now, let's proceed to the multiplication and division of scientific notation. And we will start with the multiplication rules. So we have here the rule A times 10 to m times B times 10 to n. So we're going to multiply the coefficient, the two coefficient, letter A and letter B, and add all the exponent. So that is why we have times 10 m plus n. Alright, so this is the standard format that we are going to follow if we're going to multiply the scientific notation. So the steps are: number 1, you're going to multiply the coefficients; number 2, you're going to add the exponents; and number 3, you're going to normalize the number if needed. Okay? Now, this is the example for the multiplication of the scientific notation. So the given is 7.5 times 10 to negative 2 times 4.0 times 10 to the 5. Okay, so what we're going to do, we're going to multiply the coefficient 7.5 times 4.0, and we're going to add all the exponents, the negative 2 and the 5. Alright, so since it is negative 2 and it is plus positive 5, so we're going to subtract the two numbers, and we're going to use the sign of the larger one. That is why we have positive 3, okay, as the exponent. So 7.5 times 4.0 is equal to 30, or 30.0 times 10 to the positive 3. Now take note that this is not the standard format. We're going to change the position of the decimal point here. So we're going to move one place to the left. So that becomes 3.0 times 10 to the 4. It is 4 because we move the exponent once towards left. Now next is the division of scientific notation. So we have rules to follow here. Now the rule is A times 10 to m divided by B times 10 to n. You are going to divide the two coefficient, the A and the B, so that will be A divided by B, and subtract the exponent. So that is why we have times 10m minus n. Okay, so the m is the exponent of the first scientific number, and the n is the exponent of the other one. So we're going to subtract the two, okay, and divide the coefficient. So the steps that we're going to follow are the following. Number one, you're going to divide the coefficient. Number two, subtract the exponents. And lastly, you're going to normalize if it is needed. All right. Now, this is our example for the division of scientific notation. So the given is 4.5 times 10 to negative 3 divided by 9.0 times 10 to negative 6. So what we're going to do is we're going to divide 4.5 by 9.0. So that's 4.5 divided by 9.0. And then we're going to subtract the exponents. Now take note, in this case, the exponents are all in negative signs. Okay, now if that's the case, we are going to um, change this one into um, a positive form. Okay, take note that um, minus negative 6, we're going to change all the negatives into the positive and subtract since 3 is in negative. Okay, again, the negative 3, its sign will retain. However, because of minus negative 6, we are now going to change the sign of 6 into positive. Now take note that a positive and a negative sign, that will force us to subtract the two numbers and follow the sign of the bigger number. Okay, that is why it is positive 3. Okay, I hope that is understood. So 4.5 divided by 9.0 is 0.5, and the final exponent is times 10 to the positive 3. Now, take note that the 0.5 is not as the standard form or format of the scientific notation. So we are going to move the decimal point from its original position to the right. Okay, so that becomes 5.0 times 10 to the positive 2. Okay, so take note that by moving the decimal point from left to right, that reduces the number of exponent. All right, now next is we have 4 items as your practice problems. You are going to multiply the scientific notations as divide. Now, item number, letter A, 2.0 times 10 to the 6 times 3.0 times 10 to the 2. For letter B, 9.6 times 10 to the 3 times 1.5 times 10 to negative 5. For letter C and letter D, you're going to divide the numbers. So 8.4 times 10 to the 7 divided by 2.1 times 10 to the 3. And letter D, 6.0 times 10 to the negative 4 divided by 2.0 times 10 to negative 6. So you have to pause this video to answer the 4 items. And after answering the 4 items, just play again the video to see the final and correct answer. These are now the solution of the 4 items for the practice problems. So for letter A, again we have 2.0 times 10 to the 6 times 3.0 times 10 to the 2, and we multiply the two coefficients, the 2.0 and the 3. So that's why we have 6.0 here, and add all the exponents because this is multiplication. So 6 plus 2, that's why we have 8. Alright, so our final answer is 6.0 times 10 to the positive 8. Now in letter B, take note that our exponents are not of the same um, signs. and not of the same values. Okay, so what we're going to do is we're going to multiply 9.6 and 1.5. So 9.6 times 1.5, we got 14.4. All right. Now, um, about the exponents, we have 3 uh, plus uh, negative 5. Okay. Now take note that 3 and 5 are not of the same sign, so we're going to subtract the two numbers and copy the sign of the bigger one. Now in this case, the 5 has the biggest, the is bigger than 3 in its absolute value, so we're going to copy the negative sign of 5 here. So 3 minus 5, that is negative 2. So the answer is 14.4 times 10 to negative 2. Now take note that we have two digits here before the decimal point. So what we're going to do is we're going to change the decimal point again, move from its original position to the left. So we arrive with 1.44, and also we're going to change negative 2 and reduce that one into, change that one into negative 1. Okay, I hope that is understood. Now in letter C, what we have here, we have 8.4 times 10 to the 7 divided by 2.1 times 10 to the 3. All right. Now, as what I've said, that the rule of dividing the two significant figures, you're going to subtract the two exponent. Now, in this case, we have 7 and 3. That is why we have 7 minus 3, because this is division. And we're going to divide the coefficient, the 8.4 and the 2.1. So 8.4 divided by 2.1 times 10, and the exponent 7 minus 3. So that is why our final answer is 4.0 times 10 to the 4. And lastly, for letter D, the given is 6.0 times 10 to negative 4 divided by 2.0 times 10 to negative 6. Now take note that all of the exponents here are all in negative sign. Okay? So that will be 6.0 divided by 2.0 times 10, and the exponents negative 4 minus negative 6. Now take note that we have two negative signs here, so we're going to change 6 here into positive. So that will be negative 4 plus 6. And because they're of opposite signs, we're going to subtract them, and we're going to copy the sign of the larger number. That is why we have 2, and it is positive. So the final answer for letter D is 3.0 times 10 to the 2.